Okay, so I kind of talked a little bit in that last video about this idea of finding areas of rectangles under a curve, and that's how you can approximate what the area under the curve is. So that's what these three ideas are right here, and there's really three different ways to do this. One way to do it is to use right endpoints. So what we mean by that is on the right side of each rectangle, it touches the curve. So the top right side of the rectangle touches the curve all the way down, okay? Then there's left endpoint approximations. In that case, the left endpoint, the top left point on the rectangle touches the curve all the way down. The last way is the midpoint approximation. This one is the most accurate out of all of them, but it is a little more difficult to find. So let's talk about why it's more accurate. In this first one, if you look, there's a whole bunch of gaps here underneath the curve. So this one is an under approximation. I'm not going to have quite high enough of an approximation to make it exactly the area under the curve. This one is a slight over approximation because my areas are going to be a little bit more because I have these that kind of hang over the edge, right? This one right here, I have some of each. I have a little bit that's on, let's see, right here's a good example. I have a little bit that's under the approximation, and then I have a little bit that's over the approximation. So those two end up kind of canceling each other out for the most part. So this is more accurate then. Okay, so then how do we do this? So this first one, use this curve, and they want me to talk about it from 0 up to 3 for my x values, and they want me to have 6 subintervals. Now they have a few different ways to say this. 6 subintervals could mean 6 rectangles. It's the same thing. They could also say that n equals 6 still means the same thing. All of those things mean I'm going to have 6 of these rectangles underneath here that I need to find the areas of in order to approximate my area. Okay, so the first thing I'm going to do my right one. I'm also going to do a left one and a midpoint one for you to see how to do each of those. But the first thing I have to do is sketch this curve right here. So I'm going to plug in these values from 0 up to 3. If I plug 0 in there, 0 squared is 0. If I plug 1 in there, 1 squared is 1. If I plug 2 in, 2 squared is 4. And if I plug 3 in, 3 squared is 9. So I end up with this curve. So essentially what I just did is I made a table, and I plugged in 0, 1, 2, and 3 because that's what they told me to use right here. And I plugged them into this function in order to get my y values, okay? So then I've got this curve happening. I know it looks something like this. And I'm going to try to find the area from right here up to right here, 0 to 3. The problem is I need 6 rectangles, 6 subintervals. Okay, so the problem is this right here would be 1, this would be 2, this would be 3 rectangles, right? I need 6, which means I'm going to have to go in these half marks. Okay, so I have to think about those situations in there, and my sketch isn't perfect, but that doesn't really matter too much, just as long as you can get your areas. Okay, so I need to figure out what are my 6 areas. So I have this first one. Remember, I have right endpoints. So on the right side, I'm going to go over, and that's my rectangle. From the right side over to here, that's my next rectangle. From the right side over to there, that's my next one. This is my next one. There's my, oh, that was really bad. There's my next one. And then this last one right here is my next one. Okay, so to find those areas, I have to know 2 things. I have to know what the base is times the height. Remember, to find the area of a rectangle, you do base times height. Well, in order to find the height, I have to know what each of these endpoints are. So right here on my curve, I have to know what that endpoint is. That endpoint was at 1/2 because I was at 1 here, so halfway over was 1/2. So then that makes this endpoint 1.5 or 3/2. And then this endpoint is 2.5 or 5/2, right? So in order to figure out what my height is my y value. So I have to figure out what f of each of those values is. So right here I need to know what f of 1/2 is. And for this one I have to know what f of 1 is. The good thing is I already found that. 1 squared was 1. Remember when we plugged it in? It's just 1 squared is 1. So my next one I need to know f of 3/2. F of 2. F of 2 was easy. I knew that was 4. F of 5/2 was my next one. And then my last one, my last endpoint right here, was f of 3, which was 9. So I just need to figure out what these are in between. So f of 1/2, remember I'm squaring it, x squared. So 1/2 squared was 1/4 because you square the top and square the bottom. So 1 squared is 1, 2 squared is 4. This one, 3 squared is 9, 2 squared is 4. This one, 5 squared is 25, 2 squared is 4. Okay. Okay, so those are all my f values. Now let's talk about how to find the area. So let's look at this biggest rectangle. The area of this rectangle is base times height. And we already figured out the height of this one is 9. That was my f of 3, right? What is the base? The good thing is the base of every one of these should be exactly the same. They are 1/2 because I went over half for each one of them. So my base is 1/2, my height is 9. So when I'm looking for my area is going to be 1/2 times 9 in this case, plus 1/2 times my other values. So I'm going to go backwards. I'm going to do from 9 all the way down. So this one was 25/4. This one was 1/2 times 4. This one was 1/2 times 9/4. This one was 1/2 times 1. And then my last one was 1/2 times 1/4. Okay, so that's a whole lot of messy fraction work, but we can get there. So again, you can use a calculator for this. So this one ends up 9/2. You can simplify that if you want. I'm just going to leave it 9/2. This one ends up 25/8. This one ends up half of 4 is just 2, so that one's nice. This one would be 9/8. This one's just 1/2. And this one is 1/8. And if you put all of that together, I ended up with, I used common denominators and got 91/8. Or you could simplify that and say, really, that's about 11.375. I said about, but it seems to me like that came out perfect. Let me check it real quick. So 91 divided by 8, it's exactly 11.375 because if it's an eighth, it definitely is going to end in something pretty. So that is my area approximation using my right endpoints. It's about 11.375. Then I'm going to go and do the same thing for my left endpoints. So again, I'm going to find my rectangles. So this one right here is my 1/2. This is my 3/2, my 5/2. This time I'm using the left-hand side. So I'm actually going to go over and do this. I'm going to start from this side first so you can kind of see what I'm talking about. Here's my left-hand endpoint, and that takes me over to 3. So I'm not actually going all the way up to here, right? So just be careful with that. So then this one goes over and down. There's my second one. This one right here. This one goes right there. And then this one goes right here. It's a little bitty. And then this one, this last one is at 0. So that one's kind of a weird one. Let me point out that when I do my areas here. So I get to use the same values that I used up here. I don't have to find them again because I'm going to be using most of them again. The difference is I have to use this the left-hand side. So at first I'm using 0. right here. So 0, f of 0 is 0. The other ones that I need, the f of 1/2, f of 1, f of 3 over 2, f of 2, and f of 5 over 2, I already have all of those right here. So I'm going to be using all of these right here. The difference is I don't need f of 3 this time, right? I don't need this one, but I do need this one. So now I'm going to be doing the exact same things I did over here, 1/2 times each of those values. So the first one is 1/2 times 0. That's this area right here, 1/2 times 0. So that one's just 0. Then the rest of these, my f of, I'm going backwards. Let's go back over here. My f of 1/2 was a total of 1/8 when I did my area. So I'd have 1/8. I'd have 1/2, the next one down. I'd have 9 over 8, the next one down. I'd have 2 and 25 over 8. This is where that difference comes in. Remember, I did not need this one. I don't need my 1/2 times 9, so I don't need this one, because this height right here never happens. It's only this one. Okay, so if I add that up, the good thing is I already had this one, so really what I could do, this 0 isn't going to change anything, this one right here, but what I could do is just say this and take away this, and that's going to give me my answer, or you can add them all up separately if you'd like. Either way, you should end up with, let's minus away my 9/2. So I end up with about 6.875 for this one. Now let's look at what that means here. So remember, this one was over the curve, right? So that's an over approximation. This one's under the curve, so that's an under approximation. So my true answer is somewhere between 6.875 and 11.375. I'm not sure exactly where, but it's somewhere in between there. Okay, another thing we need to think about over time, we'll get better at this. If this is an increasing function and I have an over approximation, I need to be able to state that for them on the AP exam. So as we go further, just remember that that's important. Whether this is cupping up or cupping down, this is a concave up, but it's increasing. So this right endpoint one is going to be an over approximation in that case. Okay, so let's take a look at my last type, and that's the midpoint one. This is the most complicated one out of all of them. So when I start out on this one, I have to remember I'm using the middle of the rectangle. So if you look at my rectangles, here's my half marks. I kind of drew in those rectangles for you, but I have to use the midpoint of each of those. So I put in these midpoint markers kind of in between. So I counted by fourths. This is 1/4, this is 2/4 or 1/2. This is 3/4, 4/4, 5/4, and so on, right? So my rectangles are going to go from here, and then here, and then right here is a rectangle, and then right here. So here's the thing though, guys, you do not have to be great at drawing these rectangles. All you have to know is what value am I using, what y value am I going to need there to find the height of those rectangles, right? So I know that I'm going to start out, let's start on this end. The endpoint that I used was the midpoint, which in this case was 1/4. So I'm going to need that value. The next one I'm going to need is the 3/4. So that's the midpoint of this rectangle right here. The next one, the midpoint of this one is 5/4. So I need a whole bunch of weird values, right? The next one is 7/4. The next one is 9/4. And then the last one is 11/4. Okay, so I'm going to find f of those values. So remember, let's go back to our equation. It was y equals x squared. So I'm just going to plug those in. So 1/4 plugged into x squared there would be 1/4, or I should put parentheses around that, sorry, 1/4 like that to the second power, or you could just square the top, square the bottom. So 1 squared is 1, 4 squared is 16. So 1/16 would be the height of that rectangle. This one would be 9/16. This one would be 25/16. This one would be 49/16. 81/16, and then 121/16. Those are my heights. Now remember, I have to take this times each one of those. I have to multiply all of those by my width or my base, right? Remember, your area of your rectangle is base times height. The height in this case on this last one was 121/16. But my base, I got to figure out what that is. Well, regardless of where you were at, so let's see this one over here. It was 1/2, just like on all those other ones in my other rectangles. The width there didn't change. It's still 1/2. So all of these, to find the areas, I'm going to multiply those by 1/2. And then I'm going to add all of those up, and that total is going to be my area. All right, so this one ends up 1/32. This one is 9/32, 25/32, 49/32, 81/32, and 121/32. So what I could do, since all these ended up over 32, I could just add up the tops. So I could just say I've got 1 plus 9 plus 25 plus 49, 81, and 121. That gives me 286, so I end up with 286/32. So just take that value and divide it by 32, and you get about, that's exactly 8.9375. So that's my midpoint area. So again, looking back at the other two, those other two areas were 11 point something and 6 point something. And the one that was a little more accurate was 8 point something, which is about in the middle there.